Welcome to continuation of our discussions on topics in abstract algebra. We are going to continue with further results involving units and fields. So I welcome you to illustrations. Okay, viewers, as I said, we are going to explore further results involving units, and in this case, we are going to say, show that the units in R form a multiplicative abelian group. Now proof. By definition, X is a unit in R. Remember, your R is an integral domain. Okay. If there exists y also in R such that xy is equal to 1. Now, so if you collect all these x's with these properties, for example, x1, y1, you collect them. x2 times y2 with y2, something like that. So that the collection is this going to continue. For each x1 there is y1, for each x2 there is y2, and so on and so forth. If you collect this, you find out that these y's are going to be inverses. Okay, while the x's are going to be the elements. So you have, on the one hand, you have everyone, so this collection is going to involve an element and its inverse as a collection. So element and its inverse, element and its inverse, and so on and so forth. When you collect elements like this, what you are going to have is actually a group. For each element there is an inverse. So this implies that for any x you pick in R, there exists y in R with xy equals 1. So this implies that if you have now two elements, xy in R, you can always say xy inverse or xx inverse, something like that, whatever happens. Okay, it's also going to be in R. If that is the case, this defines a subgroup. This is the definition of, because if, why are we saying y inverse? Because if y is in R, we know that y inverse should also be in R, because R will contain elements and their inverses. Okay, so this is the definition of subgroup. Okay, and since this is defines a subgroup, this implies that if you have, if I now call this collection maybe R dash, okay, the collection of all x and the inverses that both x is in R, actually defines a subgroup. Now, this group is also multiplicative. This group is also a multiplicative group. Multiplicative group. Why? Because x, y, which we now write xx inverse, is equal to 1. So the identity is 1 being the identity element, okay, in R dash. So therefore, since the identity of R dash is 1, it means R is multiplication. It means therefore that these units, the collection of units is going to form a multiplicative okay, and in fact abelian. Okay, why do I say abelian? Because if x y is equal to 1, the identity meaning that x inverse is 1, then x inverse x is also 1. This is from the properties of inverses. So the group is both multiplicative and abelian. So I thank you and welcome you to the next presentation.